Shahar, Steiff, PCCW Global. Those of you who are not familiar with the PCCW Global, we're the Hong Kong ex-incumbent. Now the Hong Kong market is fully open, so we're no longer the incumbent, we are the ex-incumbent. PCCW Global is the global arm, so we deal with anything that goes in and out of Hong Kong, nothing that stays within Hong Kong. Whatever is within Hong Kong itself is HKT, Hong Kong Telecom. The real ex-incumbent, we're the international arm. So that's who we are. Personally, I'm also involved in MEF, co-chairing the LSO committee and a board member. So my presentation will be less on what we do with the machine learning and AI on our own network, but more an outlook of where we think we should be in the coming years. Just trying to figure out which button to press.
It's the left, right.
It's left, right, but somehow I'm pressing right. Well, there is a long delay there. Okay, so what our goal is, please. There it is. As a telco, traditionally, our role was to connect data and their users, right? This is what we did in the past. That is still a large part of our business, but we have grown beyond that. So imagine, once I get this thing to start moving, imagine a three-dimensional axis or a three-axis grid. So we have 3 dimensions here, perpendicular to each other, and one of them is where we move data through space. The other one is where we move data through time, and the third one is where we manipulate data. This is what we do. We just handle data as telcos. So the first one is called transport. We've been doing that for years. The second two are compute and storage, which are relatively new to telcos, but we've also been doing some of that. A lot of that is done by non-telco, so to speak, or you can define them as CSPs, but that's not necessarily coming from the telco, from the service provider side of the house. And if we try to put that, there's the traditional kind of services and the new services. Transport is more location-based and facility-based, and storage and compute are more cloud-based. Having that said, location of cloud services might make a big difference in terms of performance of services and meeting customers' requirements. So this is the landscape we as operators work in, right? A typical application, which we provide as telcos, uses all those 3. Actually, any application will use one or more of the 3 components, which are compute, storage, and transport. So for example, this is our branded video conferencing service, and on the right side you can see a typical scenario where we have users calling in from various devices. There's the connectivity part, the transport between the devices and the MCU, the device that takes everything and transmits everything to others. And there's also some storage required, first of course to keep the user credentials, and also to record the meeting to be able to replay it. This is just an example. You can think of any other application just as an example. And I had to put that slide with our own branded thing because that's what our marketing team insisted I do. Okay, so the network and cloud reality. Users and their information, and in a perfect world, there's one global network that connects everything. Everyone is connected to everything, and everything is fine and dandy, and everything works, and you just need to automate that global network, and voila, customers get to their data automatically. The reality is that the network is actually a mix of multiple domains, multiple technologies. Some of them deliver connectivity, some of them deliver storage, some of them deliver compute. We need to put all those together. And that's actually where machine learning and AI may be of help, because if you look at the way we use those technologies today, we try to understand what's happening on that network. We try to analyze trends, and we try to make decisions based on those trends. So we try to see what traffic flows where and when and why. Then we try to bring the content closer to the customer if it's content orientated, or we try to provide better connectivity or or higher bandwidth for requirement for places where we see there's packet drop or reordering or we receive customer complaints. So this is the reality. The reality is we have a dispersed multi-carrier, multi-domain, multi-technology, multi-clouds, and we need to get those services orchestrated end-to-end from the user to their data. Well, there we go. So let's get our goals clear. First of all, artificial intelligence and machine learning is not our goal. It's exciting, but it's not our goal. And where is my... Can I get something that really clicks here? Oh, there. Our goal is to offer agile, measurable, billable, and assured services, right? Billable is very important because we also want to make money and be able to pay for my flight ticket in here. Then artificial intelligence and ML are also, they're not the means to reach that, to achieve this goal, by the way. Don't get me wrong. If we apply those technologies, we still haven't been able to offer agile, measurable, and billable, and assured service. To get there, can you please click on my behalf? Because this clicker, there it is. The means are automation and orchestration of service lifecycle across multiple domains. This is how we actually get there. And AI, ML, and legacy technologies are basically part of the implementation of those technologies that allow us to deliver services across multiple domains. We have the legacy domains. For example, in connectivity is dedicated layers 1, 2, or 3. In nodal services, it could be like dedicated servers, cloud storage, firewalls. Innovative services or new services, you can count connectivity such as SDN or SD-WAN. And in nodal, we have cloud, NFV, all the virtual services. Big data analytics, artificial intelligence, bringing it all together. This is actually where the problem is. How do we bring everything together? How do we use artificial intelligence to get there better and faster? All right. A typical service lifecycle, which we go through as telcos, has to go through those various lifecycle stages. So we have the inquiry, the order, the delivery, the maintenance, assurance, billing, change management. That is what happens on a typical network. And a typical network is a cloud that consists of multiple domains, as I've mentioned earlier. The MEF LS architecture, which you might have seen yesterday, defines those domains as the customer domain, service provider domain, and partner domain. There could be one or more partners that complement the capabilities of the service provider in terms of whatever they cannot deliver on their own network, be that either geographical footprint or service footprint in terms of like services such as storage or compute that they might not be able to offer on their own network, so they need to contract with partners. Keep in mind that process of inquiry, quoting, ordering, which is a manual process today, and being automated, has to go across all those domains. And the fact is that we actually have each of those cycles in each of those, and we need to synchronize all those together, right? And the reality is that each of those domains may use a different technology, so it's a better issue. Now it started clicking correctly, but whatever. So the reality is that we have multiple domains using different technologies, different orchestration methods, and the end-to-end service, which could start in the application somewhere, thank you, the end-to-end service needs to flow across all those different technologies to work correctly, right? This is not as easy as it sounds. Kaput. Doesn't work.
Maybe zero touch.
It is, well, it's multiple touch. Oh, that is, okay. So, in order for all those to work, we need APIs, right? So now we talk about APIs, and I've counted 24 APIs that are required for the inter-carrier, from domain to domain, east-west sort of operations. Well, it's zero touch, but no touch. Whatever. Can you click on my behalf, please? I mean, the clicker, is there anyone there? But the clicker does not click for some reason. There it is. Yeah, okay, so we have the various life cycle stages, and hopefully we'll have the APIs working, but they seem to be broken. Oh, there it is. Sats flying in. A few more. Okay, counted 24. No, that was one too far. So counted 24 different APIs. If we take those APIs, we multiply them by the number of partners we have, which is 186. Multiplied by, so that basically brings us to 4,000 APIs per product. And we multiply that by multiple products, and the products keep piling up. This is not something which you can manage. So artificial intelligence might help us, but this is not a manageable solution. Well, there it is. So look at a federated orchestration of a bottom-up network that allows us to explore the microservices. What's happening with this clicker? Well, I'm not sure what's wrong with this clicker, but it just clicks by itself now. This is now zero touch. I'm not touching it. It happens by itself. All right. So, okay, whatever. I'll live with what we have. The number of use cases keeps growing, and IoT and new apps will just create more and more APIs, more and more use cases. If we keep building APIs based on per use case and manually building the APIs, it will just scale too fast for us to be able to deliver. Yeah, that's maybe I should click the television. Where is the receiver? I should be clicking towards. All right, so we need to develop a method or methods that can generate APIs on the go based on some sort of a modeling language, such as UML, for example, which will include the service model, which is the definition of the service, include the resource model, which is the definition of what we have down there in the network, and an information model that puts all those together. Now it's zero touch. So one of those actually exists. There is an existing toolchain, which is imperfect, but it works, which basically takes Papyrus UML and through Eagle and Swagger generates Yang. That already works. It's not perfect. It doesn't always work, but if we fix it a bit, I think it's good because we already have now a method that instead of writing multiple APIs, you see, we talk about thousands of APIs, and they keep piling up as we produce more services or introduce more apps. Instead of that, all we need to do is model the service, model the resource, model the product that you want to sell, and then voila, an API is being built on the fly, on the go, and we're ready to deliver the service. So far from perfect, but it's a good start. That's a good start where we are. Obviously, we're still sort of locked to use Papyrus UML for now. Maybe Eagle will improve and we'll be able to use other types of UML. And again, it can only generate Yang for now. Maybe in the future it will be able to generate additional types of APIs. Let's see. It's my finger. I don't know, something is wrong with my finger, or, oh, well, both require industry collaboration and, oh, now it works, okay. All right, so in order to get to that UML, and I'm sorry for the haphazard slides, in order for those to work together, we need to get the compute, connect, and store facilities work together. For that, we need to have a consistent orchestration approach, a consistent service definition, information modeling, and a consistent process. When we get all those three together, we're able to start automating services across multiple domains and multiple vendors and multiple carriers. So, as I mentioned, we need industry collaboration, and I give credits to Dave Hughes, which you have seen in the other room just before lunch. Do you recognize this gentleman? Who is that? Right. What was his famous statement? Exactly. I have a dream that we all agree on a common data model. That is my dream. And what Dave Hughes said was, I'll see pigs fly before we all agree on a common data model. He was actually using a slightly more colorful phrase, but I'll refrain from that. The issue is that we, as operators, and the industry as a whole, does not stand up and take responsibility for the different approaches. We have Etsy flowing in their direction, we have TM4M flowing in their direction, we have MEF in their direction, we have ONUP in the another direction, and we have all those vendors and carriers each providing their own siloed solution, and we can't get those to speak together. So, l'erreur, j'accuse, I accuse, but only ourselves. We cannot accuse anyone. It's not anyone's fault, it's our all fault. We are all to blame. So, power of APIs, as you know, an API connects, information is power, API conveys information from side to side, so this is an API, right? It conveys power from side to side, from the socket to the plug. But I think this API is broken, right? Why is it broken? Because we have a US socket, a British plug, and a European API, right? So what do we now need? An API gateway, right? And we even have smart gateways that we can configure, even using AI to match. But will that work? Not yet, right? Small problem as well. So we can solve that problem. Everything is solvable. We can convert 110 to 220. We can use transformators of all sorts. But it's a bit more complex when it comes to transforming 50 hertz to 60 hertz, right? But again, I'm not going to go into that. So don't rush to build APIs. First, let's build data models and the processes on both sides. If we do that, the APIs will pretty much build themselves. All right, so let's roll off our sleeves and develop the standards through which those APIs are built. I'll skip that vicious circle because I'm a bit short of time. Oh, that's the one. Okay. Do you know the story of the Tower of Babel? You do. So what happened in the Tower of Babel, if you recall? I'm not going into theology if this is fiction or truth. That's not the question. The story goes that everyone spoke one language, right? And they decided to build a tower that would reach heavens. And those up there in heaven said, if they reach heaven, they can do everything. They can basically replace us. So what did they do? They confound the language, and then the project was canceled. And this is, again, we need to ask ourselves, is it built into us? Is it I don't know, is it by creation, or is it our nature that we do not agree on a common language? Are we built to be so? Can we overcome that? Can we actually all agree on a common language? Can we all agree on a common set of rules? Or are we bound to always use those different directions? And then we can use IA and machine learning to try and analyze trends and try and improve customer experience, but we cannot really guarantee anything. A good question. So who read that book, The Hitchhiker's Guide to the Galaxy? Do you know where I'm leading to? Where to? Where am I leading to? Exactly, you got it. So Douglas Adams wrote a book, it's a trilogy, about the future where Earth needs to be removed in order to make way for an intergalactic highway. That's the story, but he had to face an issue because there were all those creatures from all over the galaxy, and each had their own language, and they had to solve the problem. So he invented the Babel Fish, which is a small thing you put in your ear, and it translates. It's instead of developing a common language, he developed a smart API gateway that allows all languages to interface with each other, and instead of 35 seconds. Instead of translating words, it translated the thoughts. Well, that was the story. He had to invent a fish because that was his API gateway, because he couldn't fathom a unified language across all the galaxy. And now, if you recall, the book ends with, "We apologize for the inconvenience," which means if we fail in developing that language, then I guess we've wasted at least 20 minutes of your time, and maybe even more than that. So that's it. So long, and thanks for all the fish. And I'm out of time, but if you still have any question and the moderator will allow me a minute, I'll be glad to answer. Otherwise, meet me after the session. Questions? Yes. Am I allowed to answer?
Yeah, thanks for the speech. And I would like to challenge a little bit this, we need to have a single language or something we all agree on, because I wonder how to achieve this. I mean, you said yourself, there's the different bodies moving in different directions. Even if you can get everybody agree on something, in the moment you agree on it, it's already old, because, well, how can you avoid that you only that you can only develop commodity services based on that, because it's already old what you have developed? How can you keep track with the development, with new use cases and so on?
Let me challenge your challenging by two examples, which you could consider as legacy, but sorry, as commodity, but you know there's still good business there. One is SS7, voice. A common standard, all voice operations use SS7, right? It's all over the world, you know. It wasn't even developed by a standard body, it was developed by AT&T and accepted by the industry, okay? But in order to trade voice today, you have to use SS7. And voice has been a commodity for years, but it's still a lucrative business. It's still a good business. Margins are shrinking, but they're still good. The other one, you could guess, BGP4, BGP6, right? It's a commodity, but if you want to send packets between domains, you have to use BGP4. There's no other way. And it's a common standard. And people are still able to show why they're better in providing IP services, even though they use BGP4. You do not need to use a new version of IP to provide good IP services. So I challenge your challenge, but I do agree. I mean, it's not going to be an easy journey.
Well, I don't say that we don't need standards for anything. Of course, standards make sense, especially in these kind of stable examples that you've given. But I would also say that these are examples from, well, traditional old legacy telco. This is not examples from IoT use cases, not examples from the dynamic app market and so on.
I think we're running out of time, so I'll be brief.
We can discuss this later.
I'll be very brief. You know, the telephone was invented 110 years ago. There was still a debate if it was Alexander Bell or Weber from Germany, or I think there was another guy that claims the fame. Telephones were provisioned by pulling twisted pairs across kilometers to talk for 70 years. 70 years. We were talking point to point, you know, with those ringing things, and you can only hold one call per line per time between two devices pre-connected. We came to manual switchboards only after 70 years that telephony was already invented. Today, it's all fully automated using SS7. On the data side, we are now pretty much on the manual switchboard level if we compare that to the old technology. Hopefully, it will be less than 70 years, right? Because data was invented around 40 years ago. So, worst case is we still have 30 years to go. I hope it will be shorter.